Thank you. Thank you everyone for joining us on behalf of the National Child Passenger Safety Board. We appreciate you being here. We're going to be featuring Airbags 201, featuring our outgoing National Child Passenger Safety Board Chair, Jennifer Pelky. I'm Brittany Lombard. I'm the Child Passenger Safety Advocate Field Representative of the National Child Passenger Safety Board, and I will be serving as your moderator today. We do have some time planned to answer Q&A at the end of the presentation, so please go ahead and enter those in the Q&A chat box. Next slide. We do ask you, please do not participate in this webinar if you are operating a motor vehicle. The webinar will be recorded and the recording will be posted to carseateducation.org within 1 to 2 business days. For our child passenger safety technicians in attendance, the presentation qualifies for 1 CEU. In order to earn the CEU, attendance on this webinar is required for at least 45 minutes. Proof of attendance will be emailed 24 hours after the webinar. As I mentioned, today's speaker is Jennifer Pelky. Jennifer Pelky is a Senior Engineering Manager in Advanced Interior Safety and the Child Passenger Safety Subject Matter Expert at Toyota's R&D facility in Saline, Michigan. Jennifer earned a Bachelor of Science degree in Mechanical Engineering from the University of Michigan, but since she was raised by 2 Michigan State University Spartans, she didn't really mean it. She joined Toyota in 2008 as an evaluation engineer in vehicle safety. Her passion for child passenger safety came with motherhood, and she became a certified child passenger safety technician in 2012 after struggling to find a car seat to fit her vehicle, which was definitely not a 2-door sports car. Additionally, she previously served as the vehicle manufacturer representative and chairperson of the National Child Passenger Safety Board and is a member of MACPS. In her nearly non-existent free time, she is an aspiring aerialist, but somehow has not yet received a recruiting call from Cirque du Soleil. She has also recently started learning to play ice hockey as a backup plan in case the whole engineering thing doesn't work out. Welcome, Jennifer.
Thank you very much, Brittany, for that great introduction. Good afternoon, everyone. As you just heard, my name is Jennifer Pelky, and I've worked in the field of crash safety for over 15 years now. And for probably about half that time, my job responsibilities included airbag reliability, which is just essentially deploying airbags in all kinds of different environmental and other conditions to make sure that they perform as expected. I've been in crash safety so long because, to be honest, I'm a bit of a safety geek. I fell in love with the field after witnessing my first crash test as a co-op student, and I haven't really looked back. What that means for you today is that I have a topic that is a little bit more on the technical side, but I'll do my best to break it down for you just in case you don't get as excited about this stuff as I do. So as we get started here, I'm going to turn my camera off just because I have a multi-monitor system and sometimes it makes me look like I'm staring off into space, but I will turn it back on for the Q&A portion at the end. All right, well, we can get this way. All right, so let's jump right into it. So going back to the very basics, what exactly is an airbag? Well, in your technician guide, you learned that an airbag is a vehicle safety device made up of a flexible fabric envelope designed to rapidly deploy or inflate when the vehicle determines there's been a crash. And you also learned that using the seatbelt with the airbag allows the crash forces to be spread over a larger area of the occupant's body. This allows for the occupant to ride down a crash instead of having the force concentrated on a smaller area of the body. Well, that all sounds great, but what does that mean practically speaking? And how do airbags accomplish this? So today we're going to go into a lot more detail, covering not only an overview of how airbags work, but also the general physics involved in a crash and the mechanics of airbags in a crash. Did someone say physics? Oh, wait, right, that was me. Why? Because as I mentioned, I'm a self-proclaimed safety geek and they gave me a microphone and an hour to talk. But also because when we're trying to understand how airbags and other vehicle features manage energy in a crash, it can really help to first understand the physics behind the crash. So if you've heard me talk before, you may know that I often start with this basic review of crash physics. So this may be familiar to some of you, but I think it's really important to frame the conversation by thinking about what the engineering challenge is. So let's kick off this conversation by talking about inertia. You may remember, or maybe you've already read ahead on this slide, But inertia means that objects in motion will stay in motion until acted on by an outside force. So in a vehicle crash, this means that the occupants continue to move forward in their original direction and speed until they're slowed down by something, typically a seatbelt, airbag, or the vehicle interior. So this video here from IHS is about 3 minutes long, but it does a really great job of explaining this concept of inertia.
Why'd this dummy get left behind? It's called inertia, the property of matter that causes it to resist any change in its state of motion. Galileo introduced the concept in the late 1500s, and almost 100 years later, Newton used this idea to formulate his first law of motion, the law of inertia. It's why the dummy fell off the back of the truck. It was at rest, and it wanted to remain at rest. That's inertia. It's the same property that keeps the china on the table as you pull the tablecloth out from under it. Now what about a body in motion? Am I a body in motion? You bet I am. I'm moving 35 miles per hour. But from one perspective, it may not look like I'm moving at all, because in relationship to the passenger compartment, my position isn't changing. But if you look at me from the outside, you can see that I'm moving at the same speed as the vehicle, in this case about 35 miles per hour. And if Newton was right, and we know he was, I'm going to keep on moving at the same speed until an external force acts on me. Now, what does this mean to occupants of a moving vehicle? Watch this. See how the car and the crash test dummy are traveling at the same speed? Now watch what happens when the car crashes into the barrier. The front end of the car is crushing and absorbing energy, which slows down the rest of the car. But the dummy inside keeps on moving at its original speed until it strikes the steering wheel and windshield. This is because the dummy is a body in motion traveling at 35 miles per hour and remains traveling 35 miles per hour in the same direction until acted upon by an outside force. In this case, it's the impact of the steering wheel and windshield that applies the force that overcomes the dummy's inertia. Inertia is one reason that seatbelts are so important. Inertia is one reason that you want to be tied to the vehicle during a crash. If you're wearing your seatbelt, you slow down with the occupant compartment as the vehicle's front end does its job of crumpling and absorbing crash forces.
All right, so let's recap. So when a vehicle is involved in a crash, it may come to a sudden stop very quickly. And thanks to inertia, the occupants of the vehicle will keep moving in their original direction and speed until they're slowed down by something, again, such as the seatbelt, airbag, or vehicle interior. But we can reduce the chance for injury to vehicle occupants by using the vehicle to extend the time it takes for the occupants to come to a stop. So this is what is known as the ride-down effect. So you may not realize it, but you probably know this instinctively from other experiences. So if you were to jump up in the air, how do you land? What are your knees doing? Well, instinctively, they're going to bend as you touch down on the ground. I don't know if you've ever tried to jump up in the air even just a short distance and land with your knees locked, but it's almost impossible because your brain really just doesn't even want to let you do that. Well, if you can force yourself to do it, you'll quickly understand why it's not ideal. It really doesn't feel great. The locked out knees cause your body to come to a stop very quickly, which causes a shock load into your knee joints. So landing with your knees bent extends the time it takes for your body to come to a stop. So let's think about some other ways you might know this from your daily life. If I were to toss, say, a water balloon to you right now, how would you catch it? Would you kind of rigidly and stiffly hold your hands out in front of you and just catch the balloon? No, not really. I mean, unless you wanted to get really wet. I mean, it's summertime now, so maybe you do. But if you didn't want it to break, you would kind of move the balloon back as your hands touched it and slow it down over time. So what if you were to go bungee jumping? If I were to go bungee jumping off a bridge and the instructor told me I had two choices, I could use an elastic bungee cord or a traditional rope, which would I choose? Well, even if the rope was several times stronger, I would choose the bungee cord, the one that would absorb energy and slow my body down over time instead of the one that would give me the abrupt stop. Well then, if extending the time it takes to stop is beneficial, what are some ways we can extend the time it takes for an occupant to stop in the crash? Well, first, we can extend the time it takes for the vehicle to stop. Crumple zones in the vehicle absorb energy and help slow the vehicle down more gradually than in a more rigid structure. So the crumple zones in vehicles act like our bent knees when we jump in the air, or that bungee cord if we chose to take our jump a little bit higher. Second, we can tie the occupant to the vehicle. So seatbelts and airbags apply force to help overcome the occupant's inertia. Seatbelts help slow the occupant down with the vehicle to take advantage of that crumple zone benefit. Airbags add additional restraint and also spread those crash forces out over a larger area of the body. Spreading the crash forces out helps reduce the chance of injury. So here are some still pictures from the video that we just watched. So in the first two pictures, you can see how much the front of that vehicle is crushing as it strikes the barrier. So if we look at the two pictures on the right, we can see quite a bit of difference when the occupant is tied to the vehicle versus not tied to the vehicle. So in the middle picture here, you can see that even though the front of the vehicle is crushing all this amount, the occupant just keeps moving forward. He's skidding along this seat at the same speed that he started at. So he's not taking any advantage of this crumple zone until he strikes the steering wheel and the windshield. Versus the picture on the far right where he is tied to the vehicle, he has some small amount of stroke, but then the seatbelt and the airbag prevent him from moving forward anymore, tying him to the vehicle. So now he's slowing down with the vehicle as it crushes. So we've seen these slow motion videos of the crash, but what kind of time frame are we really talking here? Well, it happens in the blink of an eye, literally. So quick exercise, I know I can't see you, but everyone blink your eyes. So a blink of an eye lasts about a third of a second, so 0.33 seconds. A typical vehicle crash lasts about 300 milliseconds or less, or 0.3 seconds. So roughly the same amount of time, which means that the crash is often over before the occupants even realize a crash has happened. And so when we think about airbags, they have to inflate even faster than this 0.33 seconds to help restrain the occupant. So this video is actually an older commercial from Volkswagen. And I like this commercial because even though it's still maybe not quite how it happens in real life, it does kind of give you an understanding of how accidents really do come out of nowhere. And you really might have them be over before you even know they happened.
Feeling like she's not like listening to me.
Have you tried not saying like every other word?
What?
Remember your ski trip story?
Yeah.
I was like going down the hill and like this guy like cut me off and like there was a crowd
No,
and like
come on, that's
and I
not
was like,
me.
look, stuff either happens or it doesn't happen. Stuff doesn't sort of like happen. Holy.
All right, so even though that's from our friends at Volkswagen and not Toyota, I still wanted to share that with you today. All right, so now let's talk about the physics of what's actually happening in the airbag deployment. And let's start with the steps that are needed to actually inflate the airbag. So assuming that there's no pre-collision technology such as automatic emergency braking, step one is that the vehicle strikes the object. After that, sensors in the vehicle have to detect the collision. After that, the vehicle's computer has to analyze input from multiple sensors and determine whether or not the airbag should deploy. So this could be based on the speed of the impact, the direction of the impact, what type of occupants are sitting in the vehicle. Is it a large adult? Is it a small child? All of these things have to get analyzed and a decision has to be made. So if the decision is yes, we should fire the airbag, then an electrical signal is sent to the airbag to deploy. After that, the airbag inflator ignites solid fuel, which is stored inside. That starts a chemical reaction, which then produces a gas that rapidly fills the airbag, causing it to expand out toward the occupant. After that, when the airbag is ready, now the occupant can contact the inflated airbag. So if you think about the exercise we did just a minute ago, we saw that that blink of an eye is about 0.33 seconds. So a typical frontal airbag inflation is 3/100ths of a second or less. So 0.03 seconds, which is about 10 times faster. So this means that we could deploy 10 airbags back to back, one after the other, just in the time that it takes to blink your eyes. So why do we use a chemical reaction? So the idea of the vehicle airbag first actually originated in the 1950s. And at the time, compressed gas was used to inflate the bladder, but unfortunately, it just wasn't fast enough. So imagine even trying to blow up a balloon in 1/10 of a second. It'd be really, really difficult. So in general, we need a chemical reaction to inflate the airbag in time. And a short time it is. So as I mentioned before, a typical frontal airbag inflation is about 3/100ths of a second or less, which is 0.03 seconds. A typical seat side airbag inflation is about half of that, about 0.015 seconds. So these incredibly fast times mean that we need a very tightly and precisely controlled and repeatable process. And this is one of the reasons that airbags use solid fuel, as you can see here in the picture, although the chemicals used in the solid fuel pellets vary by manufacturer. So shown here is an example of a driver airbag inflator. So you can see that we have two separate chambers of fuel pellets. So using multiple chambers is one way that we can help tune the strength of the airbag for different conditions, such as vehicle speed or occupant size. So if we ignite both chambers at the same time, that will give us our most powerful airbag, but we could stagger them at other intervals that can give us varying degrees of airbag power. So when it's time for the airbag to actually deploy, an electrical signal is received here at the black and orange pins. And then those will heat up and start the chemical reaction of the pellets. So that chemical reaction produces gas. Gas then exits the inflator through these vent holes shown and fills the cushion, which you can see in the picture on the right. So the cushion then expands, moving through the steering wheel, or if it's a different type of airbag, the instrument panel, the trim, etc., towards the occupant. So I mentioned different types of airbags, so let's talk a little bit about each. So first we have frontal airbags, which I personally think are what most people mentally envision when they hear the word airbag. They're generally the most powerful, and they actually have to meet an unbelted requirement, where we put an unbelted dummy in the front seat, and the airbag has to restrain him without a seatbelt. So because these airbags are very powerful, and because of their location, as technicians and instructors, we all know we never put a rear-facing child seat in front of a frontal airbag. Next here are knee airbags. Most people think they're there to cushion the knees, and while they do provide some load reduction into the knees and the thighs and pelvis, they actually help kind of limit that forward movement that we talked about earlier. They help tie the occupant to the vehicle. So you can imagine the occupant's knees in the middle here, and so this cushion being present helps limit how far the dummy or the occupant can move forward in the crash. Next, we have seat side airbags. These are smaller, and they have to deploy very quickly to fill the space between the occupant and the door of the incoming vehicle in a side impact. They come in lots of different shapes, such as the torso airbag that's shown on the front seat that covers primarily the torso area, or in the rear seat, we have the torso, abdomen, pelvis airbag as well. So again, they're very fast, but overall, they're less powerful than frontal airbags. And next here, we have curtain airbags, which inflate from the roof. So they offer head protection in side impact and rollover accidents. And they are actually the airbags that stay inflated the longest. And that's because of rollover accidents. They typically last a lot longer than your frontal or side impact. So those curtain airbags need to stay inflated for a period of time. All right, so I think most of us probably group all airbags together kind of in a single category, whether it's a front or a side or a curtain, they're just all airbags. But actually the way they function can be quite different. So for example, here I have two videos comparing a front and a side crash. So here we have the front crash. And if you watch the airbag as it deploys, it comes out very large, very fast, and directly towards the occupant. There's lots of space to work with here as the frontal crash has all of the front end of the vehicle in between the occupant and the impact point. Now, if we look at the side crash here, you can see the seat side airbag deploys very quickly between the occupant and the door. And the curtain airbag deploys down next to the occupant, filling that space between the head and the incoming pole. The airbag slows the head, preventing it from exiting the window or striking the pole directly. But as you can see in these two videos, in side crashes, there's much less available space to use as a crumple zone and absorb energy. So the energy management strategy is different from that of frontal crashes. And then in addition, as I mentioned, federal regulations require the curtain airbags to stay inflated for an extended period of time, protecting the occupant in case of a rollover, unlike other airbags, which inflate and deflate very quickly. So you may have noticed in the frontal airbag, there were lots of vents allowing this airbag to already be deflating, where the curtain airbag is staying nice and full. So in the curriculum, we talk quite a bit about keeping children in car seats away from frontal airbags, but not so much about side airbags. Well, why is that? So despite them all being airbags, the way they function, as you just saw, is actually quite different. So again, those frontal airbags are larger, more powerful airbags, and they deploy directly toward the occupant in a crash to absorb energy and slow the occupant. So if we think about a child in a child seat, a child restraint positions the child higher and more forward, so it would actually be closer to the deploying airbag. However, those side airbags are narrower and less powerful. They deploy in that small space between the door or glass and the occupant to absorb energy and protect the occupant from the window and the striking object. So again, if we think of our child in a child restraint being higher and more forward, it actually doesn't change the relationship to the airbag very much at all. And in fact, the boosted height of the child in a forward-facing car seat or a booster seat may actually allow for increased head protection from a curtain airbag. So while frontal airbags may pose a danger to children in child restraints, and again, we all know a rear-facing child restraint should never be placed in front of an active frontal airbag. Sorry, I have to say it again. Children in child restraints, again, may benefit from increased protection from those side airbags. And studies from NHTSA and Transport Canada have shown that seat side airbags and curtain airbags do not pose a significant risk to children in age-appropriate, properly installed child restraints. So this is why, unless otherwise specified by the manufacturer, you may install a car seat in a location with side airbags. All right, so let's talk about FMVSS 226 ejection regulation, or ejection mitigation. So as regulations go, it is a fairly new regulation. It applies to most passenger vehicles manufactured on or after September 1st, 2017. It really is looking at retention of a dummy head and a daylight opening. Well, what does that mean? So I'm going to start these two videos now because these are high-speed video, but that means we'll see quite a delay between when we send these dummy heads in. So what you'll see on the left here, we have an airbag that was not compliant with FMVSS 226, and on the right, we have one that is compliant with FMVSS 226. And again, since there's a requirement to keep these airbags inflated for a period of time, that's why we've got the big delay here. But on the left, you'll see that the head is able to escape because there's no window present and the design of the airbag. Whereas on the right, the design of the airbag, even though there's no window present, is able to retain the head inside. All right, so now I'd like to talk to you about another type of testing for airbags called out of position testing, which I've actually found that a lot of people don't seem to have a great awareness of. So this testing is actually part of NHTSA's new car assessment program, or NCAP rating. And it provides consumers with more information about how their vehicle side airbags perform. It's more or less a worst case scenario test condition where an unrestrained occupant is directly in the path of a side airbag. So you can see from the pictures here, we have the backwards child laying on the seat bolster, right where the side airbag would deploy. Here you have a child kneeling on the seat with their head touching the glass. Here's a child kind of laying across the seat. So this testing uses unrestrained 3 and 6-year-old child dummies, as well as the small 5th percentile female side impact dummy. So one thing to keep in mind with this testing is that, of course, a child who's properly restrained in a child restraint is much more protected than the dummies in these testing. They would be outside the deployment path of the airbags. So this is an example of an out of position test. This is actually the small female dummy in the front seat. But I chose this test because even though it's a female, 5th percentile and in the front, her head is actually touching the glass at the start of this test. So as the curtain airbag deploys, even though her head is already touching the glass, it's still able to sneak its way in between her head and the glass and would protect her head from any oncoming vehicle or pole or tree in a vehicle crash. So again, in a similar way, if you had a child in a child restraint next to a curtain airbag, you would expect very similar performance where the curtain airbag is able to sneak down in that space between the child restraint and the glass or door or whatever it may be. So how can you find information on whether or not a vehicle meets the OOP testing requirements? So the first thing to do is go to NHTSA.gov/ratings, and there you can enter the year, make, and model. From there, it's a little bit challenging to find, but if you scroll all the way down to the bottom of the yellow section, you can click on this all safety features arrow, which will then show this additional information. At the bottom, you can see whether or not the vehicle meets out of position requirements. As an added bonus, you can also see all of the airbags that are available in the vehicle listed as well. So what are the side airbag takeaway points for CPSTs? What should we tell parents about side airbags? So the first is that side airbags really do differ from frontal airbags and that they deploy next to the occupant rather than directly toward the occupant. So children who are restrained in forward-facing child restraints or booster seats actually may benefit from increased head protection from curtain airbags due to that boosted height. It raises them closer to the height of the adult. So to keep children out of the direct deployment path of airbags, prevent children from leaning their heads or bodies against the door or window. So if children are still at the age where they fall asleep in a vehicle, a 5-point harness or a high back booster may help them stay in position even if they fall asleep. So this picture here on the right is my little guy, Gavin. He's a bit older now, but I think he was about 7 years old in this picture. And he really wanted to be out of his 5-point harness, but he was still falling asleep in his car seat like this all the time. And so as a parent, I made the choice to be unpopular with him, but know that even if he fell asleep in his car seat, he was still staying in the proper position during the ride. So with all this talk about airbags, are they really effective? So this is, I think, a pretty interesting story. So on March 12th, 1990, a Chrysler LeBaron sedan and a Chrysler LeBaron convertible collided head-on in rural Virginia. And so you can kind of see from the damage, this is kind of that typical one vehicle crosses the center line type of impact that IHS tests for. And so when the first responders arrived on the scene, due to the extensive damage to both vehicles, they completely expected to find fatalities. But to their surprise, both drivers were out of their vehicles walking around, inspecting the damage. And this was actually the first known collision where both vehicles had airbags that deployed during the crash. So these pictures are actually from the lobby of the Insurance Institute for Highway Safety, where these vehicles lived for quite some time. They've been replaced by another display now, but really, really interesting, at least in my opinion. And I know when I was younger, I remember my first vehicle that I had that had airbags, and this was in the 90s, dating myself here. But I remember when airbags first came out and hearing stories of some of the injuries caused by airbags for smaller occupants, and I wasn't sure that I even wanted them in my vehicle. But then I did a safety co-op rotation at another manufacturer, and I saw my first crash test, and it was actually a competitor vehicle. And I watched the test, and the whole front end at the end was, really crumpled up. I remember saying to my mentor, I was like, well, I guess I definitely wouldn't want to drive that vehicle. And she'd correct me. She's like, no, actually that vehicle did exactly what it was supposed to do. The front end crumpled, it absorbed the energy, it protected the occupants, the occupant compartment is intact. And the airbags, really did what they were supposed to do to reduce injury. And so once I looked at the crash more and looked at what the airbags were doing, I decided, you know what, I completely changed my mind, 180 degrees. I now didn't want to own a vehicle that didn't have airbags. And so I won't read all of these statistics to you, but the key point here is that yes, airbags are an effective tool to reduce injury in a crash. So from 1987 to 2017, frontal airbags have saved over 50,000 lives, and that's just frontal airbags. But again, airbags and seatbelts are designed to work together, and as these numbers show, the greatest risk reduction comes when you're using both. So as an 80s kid, I've always been partial to the Back to the Future movies. And so if you've seen them, you'll recognize the photo on the left. It shows Doc and Marty flying the DeLorean over Biff's car. And Marty says, "Let's land on him, we'll cripple his car." And then Doc replies, "Marty, he's in a 46 Ford, we're in a DeLorean. He'd rip through us like we were tinfoil." And while funny, it also illustrates an often held belief, I think, that older vehicles were built more robustly, almost indestructible, and that modern cars are lacking. And I know I personally used to get into disagreements with my uncle who owned a body shop. He would often complain about modern vehicles deforming under what he deemed to be very minor collisions, and certainly thought that older vehicles had an advantage. This video here on the right, though, from IHS, really does a great job of illustrating why this may not be the case. Vehicle safety has really evolved dramatically over the past 60 years, and modern vehicle structures, seatbelts, and especially airbags help provide a higher level of protection.
That's the Insurance Institute for Highway Safety's front crash of a 2009 Chevrolet Malibu in 1959 Chevrolet Bel Air. In slow motion, you can see the differences in how the new and classic cars perform in this version of the traditional frontal offset test. The Institute conducted this test to commemorate its 50th anniversary, and it dramatically shows how much improvement has been made in passenger protection since the nonprofit organization opened its doors. The two cars collide in an explosion of metal, glass, and plastics. Where the Malibu crumple zone absorbs much of the crash forces ahead of the windshield, the Bel Air structure allows the lighter car to compress the passenger compartment. The impact is made worse for the Bel Air driver by the lack of airbags, head restraint, and even a seat belt. As a result, injuries to the neck, chest, and both legs would be likely. Consequently, the Bel Air receives a poor rating across the board. On the other hand, the modern Malibu provides good protection, with the dummy movement being well controlled. Measures indicate a low risk to most body regions, though a foot injury would be possible. Beyond the safety gear, advancements in vehicle engineering give the Malibu a clear advantage in this matchup. While classic cars are often considered to be rock solid, this 59 demonstrates how much better today's cars are. And the IHS has played a key role in driving these advancements. In the past 50 years, the Institute has made a real impact. The roads today are safer for it.
And as you heard in this video, so this was a 2009 Malibu, which to me sounds pretty recent, but when you think about it, it's almost 15 years old. So that means we've had 15 additional years of vehicle safety evolution beyond what's shown in the two vehicles in this video. So let's talk a little bit about emerging rear seat technologies. Future regulations and ratings may put more focus on rear seat occupant safety, and the evolution of autonomous vehicles may change the layout of vehicle interiors dramatically. So as technicians, we need to be on the lookout for changes in the rear seat environment that could impact the way we install car seats. So one example of this is the possible addition of more airbags in the rear seat area. I know I was surprised back in 2019 when I saw that Car and Driver published an article indicating that Mercedes-Benz was developing a type of tubular airbag structure for the rear seat to deploy in frontal crashes. And while it does differ quite a bit structurally from what we typically think of when we hear frontal airbag, and from what you've seen so far in this presentation, not long after, the 2021 S-Class became the first vehicle with rear seat frontal airbags. And at first glance, this might seem downright alarming to us as technicians, but it's important to keep in mind what we learned in our technician training. When we have questions about any vehicle feature or new technology, we can always start by going to the vehicle owner's manual. And in this case, checking the owner's manual shows that the rear seat airbag can be disabled via the multimedia system. Now, if I didn't find the information I needed in the owner's manual, and if I still had questions, what would the next step be? Well, reaching out to the vehicle manufacturer. So I've only been in the crash safety field for about 15 years, but I can pretty confidently say that we are in a period of rapid change. And that's saying a lot for me because I've taken a few personality tests and they've all concluded that I don't particularly like change. But regardless of that, the evolution of AVs, development of new regulations, and other factors may drive technology additions we haven't even considered yet. But in this time of rapid change, the basics still hold true. Check the owner's manual, and if needed, contact the manufacturer. So what do I want you to remember from today? So first, airbags work with seatbelts to reduce injury by extending the time it takes for the occupant to come to a stop in a crash and spreading the crash forces out over a larger area. Airbag deployments happen very quickly, in less than a blink of an eye. And again, a rear-facing child seat should never be placed in front of an active frontal airbag due to the strength and location of the passenger airbag. I know you know this, but I have to keep saying it anyway. And again, studies have shown that side airbags don't pose a significant risk to children in properly installed car seats. So unless specified otherwise by the manufacturer, you may install a car seat in a location with a side airbag. Then finally, as technology evolves, watch for additional airbags in the rear seat area and be aware that they may affect the way you install a car seat. So now we'll switch gears a little bit and talk about the Takata airbag recall. Hopefully by now, everyone has heard about the Takata recall, but just in case, I have this video that Toyota made back at the beginning of the event. I think it does a good job of providing a nice overview of the issue.
Hello, I'm Chris Nielsen, Chief Quality Officer at Toyota Motor North America. I'd like to talk to you about the Takata airbag recall, the largest vehicle recall in U.S. history. For those who don't know, tens of millions of vehicles from 19 automakers have dangerous airbag inflators that can rupture when the airbag deploys, spraying sharp metal fragments inside the cabin. Now, according to the National Highway Traffic Safety Administration, these incidents have tragically claimed over a dozen lives. And while we're thankful none of those fatalities involve a Toyota, Lexus, or Scion, we're not standing still. Because this isn't just a recall, it's a public safety crisis.
If your vehicle has a faulty airbag inflator, we're going to do our very best to convince you to schedule a repair.
We may call you repeatedly, send you letters, target your social feed. We might even knock on your door.
Because until your airbag is fixed, you're putting yourself, your spouse, your child, your best friend, or whoever is in your vehicle in danger every time you drive. Now you can change all that by scheduling a free repair today.
We know you're busy. We know this isn't convenient, but we've taken the steps to make this process as easy as possible. You don't even have to wait at the dealership. We can provide a shuttle or a loaner vehicle so you can get where you need to go.
And remember, the recall repair is free and there are no hidden terms or obligations.
So please, take a few minutes and go to toyota.com/recall.
Check your VIN or your license plate, and if your vehicle's affected, contact your nearest dealership to schedule a repair right then and there.
Here at Toyota, the safety of our customers is always our top priority. That's why we're so committed to resolving this issue as quickly, conveniently, and safely as possible. So please, do this for you. Better yet, do it for the person riding beside you.
All right, so to recap the numbers that you heard in that video. So this recall affects 19 different vehicle manufacturers, model years 1996 to 2015. 67 million airbags have been recalled. And again, it is the largest recall in automotive history. So you're probably wondering what exactly is happening. So if you remember earlier, you learned that the chemical reaction inside the airbag inflator is a very tightly controlled process using chemical pellets that burn to inflate the airbag in less than a blink of an eye. So in the Takata inflators, the propellant used was ammonium nitrate. Ammonium nitrate happens to expand when it's exposed to humidity. So over time, exposure to heat and humidity causes the ammonium nitrate pellets inside the inflators to swell, which increases their surface area. So when the pellets react or burn, they burn at a proportional rate to their surface area, meaning that the larger the pellets are, the faster they burn. So essentially, the tightly controlled process that we intended is now happening much more rapidly, and the gas is being generated too quickly, which causes the pressure inside the inflator to increase past what it was designed to contain, and it ruptures. So there are a special group of vehicles that have been identified as NHTSA deemed alpha vehicles, and they actually have up to a 1 in 2 chance of rupturing in a crash. And so NHTSA urges consumers not to drive these vehicles unless they are going straight to a dealership to have them repaired immediately. And I won't read you all of the vehicle models here, but you can see the list. So the alpha inflators, the reason that they have a higher chance of rupturing is they actually experienced high humidity at a Takata factory in Mexico before they were even installed. So essentially they had a kind of a jump on the humidity exposure. And so now that initial humidity combined with the humidity from the aging process has made them more likely to rupture. So during the early stages of the recall, replacement parts were limited. So NHTSA designated priority repair zones, giving the highest priority to vehicles located in hot and humid climates. So you can see on the map here, of course, our hot, humid states, Texas, Florida, Georgia, California, etc. We're in zone A, more the middle of the country in zone B, and the more northern, drier states like where I'm in Michigan, we're zone C. So at the time the recall was coming to light, I had a cousin who was living in Houston. He was driving, I think, a 2005 Saab, and this Saab was definitely part of the recall, had been living in a hot, humid environment. So I contacted my cousin and said, hey, has your Saab been repaired yet? He's like, no, I got the recall notice, but I haven't gotten it fixed yet. And I explained to him, I was like, Thomas, seriously, this is a big deal. You are in the prime location with the prime age vehicle. You have to go get it taken care of. So yeah. Well, I called him like every day for 2 weeks until he finally caved and just went and got it taken care of. So if you want to check for a recall, how do you do it? Well, there are a couple ways. First, you can go to NHTSA.gov/recalls and you can enter the VIN. If you don't know where to find your VIN, there are a couple of locations in the front driver's side corner of the windshield area, and then on the door jamb area as well. But there's also a great new resource, which is a program of the National Safety Council called Check to Protect. So you can find that at checktoprotect.org. And this is a really great service. It's free, and you can search by the VIN, or you can also use the license plate, and it's optimized really well for mobile. So as technicians and instructors, how can you help with this? The first thing you can do is visit checktoprotect.org. Check your vehicle, check your friend's vehicle, your seat check family's vehicles with permission. And if you find a recalled vehicle, explain the risk and share the urgency like I did with my cousin. I really don't think he really grasped how important it was. Emphasize that this is a free repair and encourage the owner to schedule the repair. Help provide next steps for them for quick action. And honestly, check events are really great locations for recall outreach. Many of our check events offer support to underserved families. They may be skeptical of taking their vehicle to a dealership. Maybe they're undocumented, or maybe they've just never had a dealership experience. Maybe their vehicle is in need of other repairs and they're afraid if they take it in, they won't get their car back. So during that check event, you're already building trust with that family, and you're showing them that you have, you're vested in the safety of their family. And so they may be more receptive to your recommendations than they would be to, someone blindly calling them on the phone, or just the recall notice they get in the mail. So it's really a great time to interact with them and kind of offer this additional service. We mentioned before, a total of 67 million airbags have been recalled. And at the end of 2022, 11 million were still yet to be replaced. So even though we've made a lot of headway, it's still a pretty serious issue that is yet to be fully resolved. And as an example, there was a pilot event at a Buckle Up for Life event in Texas, which was in that Zone A, priority repairs. And at that event, technicians obtained approval to check for recalls. And while doing so, they found that 20% of the families at their check event had an active Takata recall on their vehicle. Now, hopefully we're not still seeing 20%, but imagine the impact you can make if you're helping to check for recalls on your family's vehicles. And to point out as well, the course won't just show airbag recalls, but it could show any vehicle or any recall that could be active on their vehicle. All right, if you would like additional information on the Takata recalls, there are a few websites here. First is the NHTSA Takata Recall Spotlight. Next is the NHTSA Alpha Vehicle information, if you would like to see that list of Alpha vehicles again. And then finally, as you heard Chris Nielsen say, if you're looking for Toyota-specific information on the Takata recall, you can go to that website as well. With that, I would like to thank you guys for your attention today and for coming. These are my guys' more recent pictures. So this is Ander on the left. He's 12, still has to ride in a booster seat in our truck and doesn't like it. And on the right is Gavin, he's 9. They're the reason that I do what I do, and I thank you for doing what you do. And with that, I'm going to turn it back over to Brittany.
Thank you so much, Jennifer. We do have a few questions here. Lacey asked,